Welcome everyone, and today I'm going to show you how I took one of the most time-consuming areas on the Android development, and which is a screenshot testing, and put it on autopilot. And actually, I'm not here to talk about how to write a screenshot test. I will show you how to automate entire process, fundamentally improving developer experience and ensuring higher quality testing results. And let's dive in and see how we can put your screenshot testing in autopilot. And my name is Cagdas, and I have been working as a lead software engineer at JP Morgan Chase for 2.5 years. And I'm currently working on a Nutmeg Android application. And the solution I'm going to show you, we already have it on our app, and it makes our life so much easier. And let's have a look at the agenda and see what we are going to cover. First, I will start with the problem itself, the challenge and the pain point of the manual screenshot testing. And then I will show the solution and our vision for a fully automated, seamless workflow. And then I will introduce the tools to make this vision to reality. And finally, the favorite part is a live demo, and I will walk through with you to show the solution and how it works. And let's get started with the problem itself. So, you finish your beautiful UI and you spend some time to get a picture of it, and you're writing some manual test code for it, right? It's same thing like how you done in the unit test. But as your app scales and the design system grows, this turns into the massive high maintenance effort. And every change, you require to go back your test class and change the test class, and even add the new cases and generate the screenshots. For example, you have some composable functions, and these composable functions can have multiple preview parameters. And this parameter has, and each parameter change your structure of UI. So you need to go back and update and add the new test case. And sometimes we have big bunch of changes, and then can forget update the test classes. But if you have a good CI, you are lucky. The CI can catch the issue for you. But until that time, you change your branch and start your new cool stuff, and then your time is gone. On the other hand, if your CI is not that much smart, these small mistakes can lead to regression and slipping into the production, which we don't want to do in the professional life and in the applications, right? And this ultimately, the manual workflow slows down the development, and it opens for error. And as you see in the screen, and there's a basic setup of the screenshot testing, which use the Paparazzi. Imagine that if you have a multiple preview parameter, you need to cover these case and to make sure that nothing goes wrong in the production. And we have an amazing tool, which is a preview. It's preview annotation provided by the Compose. And we use them to visually test our component and in isolation and see them how they are reacting to different data in different states, in different data, and different devices. We spend time and effort to make our preview looks perfect. And essentially, each one of these previews is already a visual test case, right? And they show us exactly what our components should look like. And so, there's a paradox in here. If we are doing this work, and why we are having a screenshot test to getting the picture of these things, and we are taking picture of something we already carefully designed and verified. It doesn't make sense. What is the solution in there? The solution is transform this tedious the manual screenshot process into seamless automated one. And while we are doing these things, we are bringing in 3 key technologies. And the first, we will use your preview functions. We don't write a new test, and we will take these preview functions as a source of truth or our screenshot test. And then we leverage the Kotlin Symbol Processing. This is engine that does all the code generation, and it runs in the compile time and finds your preview functions and generate the test classes. And finally, we will use a custom Gradle plugin that is built for handling entire process and making sure this module has the right configuration and the generated tests in the right spot, and they run in safely. It's some kind of secret ingredient that ties everything together. And this approach gives us some huge advantages. It drastically reduces the development time and maintenance overhead, and also it improves the consistency across your UI and provides a seamless integration into any project. The workflow just works, and you don't have to think about it. And let me introduce the tools, what we have. And we use the Jetpack Compose. It's a foundation of our UI and the preview functions. And we have the Paparazzi. It's the fast, the off-device screenshot testing framework. And we will use the KSP for the code generation. And also the Gradle plugin is some kind of glue that ties and makes everything run. Together, these two, we will create a fully automated solution. And let's dive into the test generation part. And the KSP does the heavy lifting in here. And it finds all your preview functions and pick your preferred test framework such as JUnit 5, Kotes, or something else, and generate a test class under the build directory. However, we immediately hit the major problem in here. The problem is your composable functions are leaving the main source set. So the KSP generates the classes and they put them into the main source set. But the build system is strictly designed to pick the test codes from the test source set. So the classes are generated in there, but they are not running, or they are not a part of your test framework. So you might wonder, why not we just move these test classes into the new test source set? It looks like seems like a simple fix, but it comes with a serious drawback. First, you lose your developer experience, and your composable code and your preview live in different files, and so you will lose the immediate side-by-side feedback from you rely on in Android Studio. And the second one, the Android Studio simply doesn't like it. It gives you some errors and the warnings because the preview functions shouldn't be in the test source set. So it's a theoretical fix, but entirely looks like impractical and unmaintainable. So we need some kind of robust solution to solve the code problem without compromising the workflow. The elegant solution to this problem is a custom Gradle plugin. The plugin solves everything for us in a very smart way. The plugin finds a directory where the KSP placed the generated test files, and then it tells the build system, okay, treat this specific directory as a new test source set. And this simple fix actually changed everything. And once the Gradle recognizes the directory as a test source set, your test runner immediately picks your test classes. So the generated classes are not just as files on the disk. They are now active part of your test suite. As you see in the image on the left side, before the Gradle plugin, it is generated code place in the build directory. How it looks? It's under the Kotlin main source set. Start with screenshot.kotlin. It is the custom one. And after the Gradle plugin, it looks like on the right. As you see, it's a new unit test source set under the main source set. And also the plugin even goes further ahead by automatically running these tests right after they are generated. It adds necessary dependencies into your project, and the JUnit, the Kotes, the Paparazzi, what you need, and then while your project compiling, and then generates the classes, and then run the test and get the screenshot files, and then remove these dependencies from your project. Eventually, you get the best of both worlds. You keep your previews right next to your code, and then you will get fully functional automated test suite. Let's have a look at the demo and see how it's going on. Okay, now. Okay. We have a live demo in here. And let me introduce the project. I will explain to you how we get the issue in the project. And then you will see, and then next one, we will see how we are going to fix it. It's a very simple Android project. As you see, there is an app module, and our KSP is in here, auto screenshot processor, and there is some extra test module which has some our base test classes, and a test compose module which is just single annotation to help me to find the preview functions or even to filter the preview functions, because I don't want to generate a screenshot for all preview functions. And also we have this feature module which it's home of our composable functions. This is the simple composable functions. What we have, it just has a one data model, and the first one is in the first preview, non-parametric preview function, and the second one is parametric one. It has 3 parameters and showing in a both theme, light and dark, droidcon London, Berlin, and Vienna. And the test compose, as I said to you, it's just a auto screenshot annotation which helps us to identify the preview function. This is the test module. It has our base test classes. As you see, it says basic, just a basic Paparazzi instance without any configuration. And there's a single function which is a take screenshot. We will get 2 screenshots for each composable function, which is in light and dark. And also this is the processor. Let me introduce the processor because it does the heavy lifting, as I mentioned. Okay, this processor takes 2 arguments. One is the source directory, which I show you on the presentation. It's the screenshot.kotlin, whichever you can give. And then test framework. I put 2 options. I make the test framework is selectable by it depends on your module or your project configuration. You could want to run different test suites for your module. So there's 2 arguments in here. And then when the process starts, it checks the source directory and test framework. Obviously, they shouldn't be null or empty. And then it gets your test framework. Regarding your test framework, I have 2 test class generator in here. In this demo, we will go with the JUnit 5. This is a test class generator. Simply, I'm using the Kotlin Poet under the hood. It generates 2 different classes. If your preview has no parameter, it will use non-parametric test, and otherwise it will call the get parametric test function, and we will have 2 different functions. After that, when the processor starts to scan our project, it will find the preview annotations first. And then it will filter them regarding if they are function, and it will find the functions, and then we'll check this function has the auto screenshot annotation, which is a custom one. So we are not handling the all preview functions. After that, the function must be public or internal, otherwise we can't run them in a separate class, as you know. And then it gets the function, and choosing class generator and the function, we have some get generator class info function, which takes the necessary parameters and extract some package name, and also do some validation if the function has no parameter. Okay, call this class generator function. Otherwise, do this one, and has some extra validation to make sure that our compiled code successfully compile. Our code will be successfully compiled. Otherwise, if there is more than 1 parameter, we will throw an error because the preview functions can't have more than 1 parameter. And then let's see how they are work. Before I show them, I will show you, and then there's some manual screenshot test in here. It's an easy one. It used my auto screenshot test base class, and it takes a screenshot of this preview function as I show you. And let's run it and see how it works. No. This is the simple paparazzi comment, as you know. Nice. As you see, the dark and light theme screenshot is placed in there. So let's see how we generate the screenshot test from this preview. Let me clear up that one. And I will show you the necessary dependencies, how I add. First, we will add the KSP plugin into our module, the feature module. And then I'm providing the arguments for the KSP. Will consume them and generate the classes regarding this argument. Source directory will be screenshot/Kotlin, and my framework will be JUnit 5. The dependencies, it's our custom symbol processor, it's an auto screenshot processor, I introduced you. And then the next one is just an annotation of the annotation for we will use for previews. It's auto screenshot annotation module. This is. And then I'm just heading into my feature module and just annotate my preview function. So I will just compile the project. I don't have anything about the test code running in here. As you see, it gives me an error. This is the generated code. And generated code is in the main source set, but as you see, it doesn't find the auto screenshot test, which is our base class, and it can't find this my JUnit 5 extension because it's in test source set, and also my main source set doesn't have any JUnit 5 dependency. So it gives an error, everywhere is the red, so you can't compile your project. So to deal with this, we have the Gradle plugin to solve all this problem. And let's see how we solve this problem with the Gradle plugin. And this project is same configuration, just extra as a Gradle plugin. The plugin is auto screenshot test plugin, the class name. I have this extension in the Gradle, which just helps me. The developer can configure their modules regarding the preferred test framework. It just provides me some property. I can set it, and then I'm adding necessary test dependencies. Just compile only. Why? Because as you see in the previous one, when we compile the project, it gives us an error because there is no test dependencies. In here, I'm adding a test dependency as a compile only to able to compile my actual project. This compile only doesn't harm your project. It doesn't. These test dependencies are not packed into your APK or AAB, which is safe. And there are some guardian here, which is a generate screenshot. We have some Gradle comments. If this comment has Gradle generate screenshot parameter, okay, let's move on this plugin. Otherwise, we don't need to run this plugin because obviously it's not for the generating screenshot. It could be something different. So we are not configuring the plugin anymore. But with these dependencies, it's necessary. They should be there to make the project compilable. And then imagine that we are going for the generating screenshots. And we have some configuration task in here. What this configuration task does, it gets your favorite framework, and it finds your module is Android app or the library, which is some extension function. It just resolves the module is Android library or Android application. And then it finds the source set of the module. After that, it gets by name, use the get by name function to get the test debug source set from your module. And then binds my screenshot Kotlin directory as a new test source set into the existing one. Existing one is in here test debug, and the new one will be the screenshot/Kotlin, and they will bind so the Android Studio can see, okay, this directory is a new test source set. After that, we add the necessary dependencies, the KSP, and JUnit 5 and the cotest dependencies as a runtime only. In this case, the test will run. In this line, when you run the record Paparazzi debug in the task tree, if the plugin sees, okay, the command is record Paparazzi debug, I need to first call this configuration task, and this configuration task does the configuration, and then it runs the record debug Paparazzi. When this configuration task is done, it already generates your test class, and the Paparazzi will pick your test classes as a screenshot test and run them, and it will deliver the result to you. So let's see how it works. Let me show the implementation in the Gradle file. Now, we have this custom plugin in here in the feature module. And then this is the extension. Name is auto screenshot, and then the framework will be JUnit 5 in this case. Could be Cotest also. The configuration is there. As you see, there is no extra dependency in here. Let's just build the project. It's successful. And now, let's see how this droidcon screen preview function screenshots will be generated. As you see, I will show you there is no any manual screenshot test. And test folder is all empty. So you see it's a Paparazzi, the clean, I'm cleaning, record Paparazzi debug, and this is the parameter now. The Gradle understand the parameter is there, it will do all configuration. Nice. The screenshots are there. This is the dark one, this is the light one, and I will show the generated code to you. It's not looking in the presentation because the Gradle does the thing and then remove the dependencies. This is the generated code. Now it's all green, no red errors in here, which is good. And then this is a screenshot, which is the name of the function, and this is my appendix and the screenshot test and test, because it's a name of the test, display name of the test, and then screenshot dark and screenshot light. Now we have the all screenshots. Now let's see in some kind of live coding to see how we can get the screenshots for with the preview parameters. You see, this is the droidcon screen multiple preview. This is the preview parameters. I'm just providing a title and some colors to make the screenshots fancy in here. And these three parameters looks like in here. And I will put the auto screenshots annotation here again. And we'll run the same command. Okay. It gives an error because each test should have some name, right? With these names are used by the PNG file, so we can understand this PNG file, this screenshot is just for this test. But in the preview parameter provided by the Compose, it just gets some, the sequence, and under the hood, we can just only reach the index of this sequence. So in here we have another solution. We have our own interface, the screenshot preview parameter provider. It implements the vanilla Compose preview parameter provider, which is fine. We have just extra touch in here, and we are adding a name for each parameter. So let's see how it's work. The new name is new preview parameter provider name is 2. I will show you how it works. Now, this is the implementation of new parameters. This is the model for the consumed by the preview. This is the name. Under the name of it's just a Kotlin thing, it just creates a new data class which has name and the data. This data consumed by the preview and the name will be consumed by the screenshots. So, and there are same parameters and with the names. So I'm heading here and yeah, let's rebuild. needs to clean. It will clean and run the screenshots, by the way. Okay. As you see, all the images are generated by this is the old one. Let me remove to prevent confusion. And this is our function, droidcon screen multiple previews, screenshot test, Berlin dark, and light, and London dark light, the VN dark light. It's all there. As you see, the screenshot has the name of the parameters. Let's have a look at the generated code. I'm using JUnit 5, the dynamic testing here. It gets the instance of the preview parameter provider. It gets the parameter. It checks the name if there is any duplication. If there is a duplication, because in the compose side, in our actual code, we can't check it on the, but in the runtime of the test, we can check. If there is something, a duplicated name, and just throwing an exception to make, because we don't want to override the previously generated test with the same name. If everything is fine, it gets this parameter. It uses the name as a test name, and it uses the data as a preview data. So let's head back to the presentation. Okay. Let's talk about the results in here. As I mentioned, we are using on our existing project, and we have over 1,000 screenshot files with 0 manual test code written. So, and what is the advantage of this? We are just in the project, we are just reviewing the images, not the test codes, because in the screenshot test code, we don't need them. We just need the generated images. And also, it gives us a time. We are spending to make beautiful and perfect and our composables, and we don't need to spend some time for testing. And another ways it helps us to ship faster. We are just fixing and running the command, and the screenshots are there. No need to write any code, and it's all done. Let's talk about a bit the improvements, what we have. And as you see in the project, I'm having this base class as a hard-coded, which is not hard, actually it's in the module. I'm consuming the base class from the module. But what you can do, you can generate this base class regarding your project needs. And instead of consuming it from some module, you can generate this base class. Your modules could be used by another application also. So you might need a different base classes for different module and Paparazzi configuration or whatever. It depends. And also you can use the preview functions directly. If your project needs the screenshot for each preview function, okay, you can use preview, and you can inherit the device spec from the preview, and you can give this device spec to the Paparazzi, and you will get the exact same PNGs what you see in the Android Studio. And in the current project, and we have 3 teams, and we are supporting 2 applications. We have some complex configuration about the base classes. So we have some kind of doing the different, serving different app, doing the white labeling. And before the wrap up, I just want to mention another session, which is my friend in the Josh. He will give a talk about the white labeling and tomorrow. And its talk is for you if you are interested in a scalable design system. You can come and see. And these are the resources. And thank you for joining. If you have any question, ready to answer. Yep. Yeah, we were using the Paparazzi in the manual testing, so we just implemented using Paparazzi, but should we work on the Roborazzi, right? Should we work on this Roborazzi? If you replace the Paparazzi one, if your test runner is Roborazzi, you can use the Roborazzi. Yes, please. As you see, there is some if check in here. If it's not a screenshot test generation command, it won't do any KSP stuff. So in this case, it will eliminate the all code generation part, and your project will compile as is. And for example, in our project is 1,000 file. It's just a screenshot testing. It depends on also your CI machine. It takes 6 or 8 minutes to generate these all screenshots for us. With this card, we are preventing the overheads because we don't need to generate them. Yes, please. In the CI, they are not generated. In the CI, as I say, we have you can have some separate comment, just generate a screenshot test task. So, and you're compiling your project in the CI, it's different. In the Gradle plugin, which prevents your CI to generate the screenshot test classes. So in this case, your CI doesn't get any error because your job in the CI, it depends on your configuration, by the way. In the job on your CI, if it's just for compiling the project, it won't generate any test code. It will just assemble your project and pack it up and give you some APK or AAV. But if your job in the CI is for the screenshot testing, okay, it will just generate the screenshot test classes and run them. That's it. Oh, there's another comment. There's another command in the Paparazzi. It's a verify Paparazzi debug. And when the developer generates a screenshot test, we are pushing them into the remote, and the CI will run the verify command. So these images are already in the version control system, right? And then when the Paparazzi verify command run, it just check the generated in the base images and the generated one and the verify it. So this is just for generating screenshot tests, yeah. Yeah, you can do. You mean the base test classes, right? But in this case, you will just generate the test classes. And how it helps in this case, because in the screenshot testing, we don't need a test class actually. We need the output of it, right? In the unit test, we are getting the output, the coverage, and if there is failure or not. The output of this screenshot, the output of this topic, it's in the PNG files. So if we just generate the screenshot test classes, they will be there, but they need to generate some output. The output will be the PNG. So generating just test classes doesn't make that much sense, if I understand correctly to you. You need to verify in your, right, it's in the base image every time. If there is no image, okay, the first image will be your base, right? But if there is some base image of my screen, if I made some mistake, but I generate it, and I commit it, and in the code review, the people will have a look, okay, there is something missing in here. Eventually, it will depend on some human review to compare these PNG files, not the test classes, just the PNG files. No worries. Sorry, I didn't hear you. You asked about the showcase. What showcase? Yeah. Actually, I don't understand this showcase section. What's the meaning of the showcase? Yeah, this is the KSP finds it as a showcase, and then the Gradle plugin tells it, okay, put it in this test source set, and then the Paparazzi can pick the test class and run it. I know. Okay. Okay. Oh. The thing is, the Paparazzi, I think until 1.4, the Paparazzi class itself, they extended from the test rule. The test rule comes from the JUnit 4. Actually, it was another challenge. I didn't want to go in the detail in here. And the JUnit, it's a JUnit 4 rule. And when you use on the JUnit 5, it doesn't initialize itself because it's a JUnit 4. So in there, we did something tricky, and then you get the Paparazzi instance and write some JUnit 5 extension and initialize the Paparazzi and run the test and then release the Paparazzi resource. And we made it the same thing also the cotest. And also we are using cotest in the project, and we have some kind of thing. But as I know, in the 2.0 release, they will change it. They will make the Paparazzi class and some standalone individual class, and then you can consume it in anywhere, so like a library. Yeah, you need to write our own extension to instantiate the Paparazzi, and it has some under the hood. There is some extra preparation stage and then release stage, but they are all designed for the JUnit 4. Yeah, you need to be tricked to Paparazzi to use it on the JUnit 5. Yeah. Please. Okay. Yeah. Mm-hmm. Definitely it will be first party library, and then my opinion is, and still since it's an alpha, and I think this project is a 1 year old, since it's alpha we didn't use it because of the project needs and the security concern and the working on some financial app. We built this one. The Google approach, since it's a first party approach, will be also good because always will be support to it, but their solution is here, and with the new we will get the upgrade our Android Gradle plugin because they will bring the new test source set for us. Its name is screenshot test. We will have main test and screenshot test, and you will put your previews into this screenshot test source set, and then you can run your test. So yeah, still alpha. I don't know. This is still alpha. I am just looking in the last time. But let's see when they done it, and we will definitely compare and see. Yeah. There is an if block in the plugin. If your comment doesn't have this parameter, the plugin stopped work and it won't generate anything. And it will prevent the overhead. And this parameter will be just in the CI for the specific screenshot test generation job. So in this case, no more the test code generation. No. What you mean on the building your app? It's just for run. Okay, if you run, you will start with the assemble debug, right? It's in the building your app. So the assemble debug and doesn't have any extra parameter in the command line. So Gradle won't run the plugin because it will check the command and find the necessary parameter and run the screenshot, generate the screenshot test. And you should specifically put some comment to generate the codes. Yeah. No, Okay, in this case, if it's a new if it's a new composable with you annotated, the old screenshots are generated in there, right? The KSP knows that it's the incremental build. It knows the tests are there, so it won't regenerate the existing text. It will just pick up your new annotation, and it will just generate the code, generate test codes for your new composable. Okay. If it doesn't matter because your test just run your composable. If you make change inside it, doesn't matter because eventually your test will call the function. That's it. If you change the name of the function, yeah, it will be regenerated. But if you just make a change inside the function, it doesn't matter because the generated test code will just call the function. Okay, I think that's it. Thank you for joining.